Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So in our today's lesson, we will discuss about the separating technique that is known as the solvent extraction. So mainly when we are going to talk about the solvent extraction, it is the important technique of the chemical analysis. The chemical analysis mean when we are going to do the analyze of the any substance that is known as the chemical analysis. So by definition, we have the solvent extraction. It is also known as the liquid-liquid extraction. And in this method, we need to separate the compounds that is based on their relative solubilities in two different immiscible liquids and usually water and an organic solvent. So here, in the simple words, what does mean by it? For example, we have a solution. That solution is containing water plus organic solute plus inorganic substance. So the main thing that we want to do is to remove that organic solute or to separate out that organic solute. For this purpose, what we will do as these are two liquids and they are miscible. So the main step we will add another solvent in this solution. When we add more solvent the solution, now what type of solvent we will add that solvent that is immiscible with the solution. It is immiscible in the solution. That solvent only can dissolve the organic solute in it. So this solvent will get dissolved these organic solute particles in it. So the solubility of these is more in the solvent as compared to the water. So we will gain the two layers in the solution and then we will get the separation by the help of a funnel that is known as the separating funnel. So we will use the separating funnel for this process. Separating funnel. Now how this process will take place, have a look on it. The simple process of solvent extraction. This is the simple picture of the separating funnel, and the separating funnel is having the olive oil and the water. So when we just open this, the water will be over there and we have just layer of olive oil over it. So this is main the separating funnel. Another more important example for this we can have the example of iodine. Iodine as its formula is I2. Now what is going to be take place in the iodine? Iodine is present in potassium iodide. When potassium iodide is present in the water and in the carbon tetrachloride CCl4. So here we can see that the iodine reacts with the simple iodine ions that are present in the aqueous solution and it just form the iodine I3. Now this triiodide ion. This is known as the triiodide ion. When we have a look on this triiodide ion, it is more soluble in carbon tetrachloride as compared to the water. So when there is a formation of I3 in the aqueous solution, we just add the carbon tetrachloride. Now that iodide comes into the CCl4 and its distribution will be in both phases. where that I do it is soluble in carbon tetrachloride as it is present in the aqueous solution, so it will be more soluble in the water. So we just gain the I2 in CCl4 back, and the next step is the iodine molecules will be in the organic layer as I2, and in the aqueous layer they're left behind just the iodide ions. In this way, we can separate out this organic layer which is having more dissolved iodine in it. And all this process is just takes place on the basis of the law that is known as the law of distribution. And in this law, the soluble solute distribute itself in the two immiscible liquids. So here the aqueous layer and the organic layers are two immiscible layers, and the solute particles distribute itself in these two layers, like these two layers. These two layers are mainly insoluble into each other. After we have another example for the solvent extraction, the main example in the solvent extraction we have the ether extraction. So for the extraction of the different organic compounds from the aqueous layer, we use ether. For example, in the step 1, we have ether that is added to the aqueous solution A. Here, this is the main aqueous solution, and we add ether in it. And the formula of ether we have simple ROR, where the R are the alkyl groups. After the addition of the ether, now there is a formation of two layers. So the solute particles that are organic in nature, they distribute itself in the two layers. So now they are going to the ether layer, and from ether layer they're going to the aqueous layer. Now that water which is present on shaking, it distribute between the ether and water layer. We just get separate out the water layer, and over there we have the ether layer. Now how we can remove the solute particles? By the process of the evaporation. All the ether will get evaporated, and we just gain the solute particles left behind. So this is the main separating process that we can use. And here we have the distribution coefficient, that how it distributes itself between two layers. It is denoted by the K, and we can also write it in the previous lesson as we have learned the solute concentration of solute in the organic layer or in the ether layer divided by the concentration of the solute that is in the aqueous layer. So this is mainly the distribution coefficient that can be explained on the process of the solvent extraction. I hope you guys understand the process of solvent extraction. And the next we will discuss about the next topic, which is chromatography, which is also very important and very interesting. For that time, you guys have a good day and Allah Hafiz.